This is in response to a question that came up in Math 95 recitation class regarding how you can go ahead and create a quadratic equation given that you have the graph. And before I do an example on that, and I got this information directly out of text, so it's not like I made it up. You can find it easily yourself. This is in chapter 9, I think it's 9.6 or 9.7. Anyway, take a look at these two parabolas down here. You'll notice one is going down and one is going up. Well, the deal is on parabolas, they all pretty much start at the same place. Their vertex starts right here at the origin. And whether it goes down or up is determined by the coefficient of that first term, of the x squared term. If it's negative, it's going to go down. If it's positive, it's going to go up. But again, it's going to face down or face up. But again, there's a shift on here, you'll notice. And that shift is in accordance with this +3 here. So it started here at the origin and then got pushed up by 3 units. And over here, because it says -3, that parabola then dropped down by 3 units. And that's that number right there, the +3 or the -3, is this k that's part of this format so far. And that's going to tell you what's happening in a vertical sense. This is directly out of the text. This is the format that you're going to use for the quadratic form, and this is in vertex form. And it's important, really important, that you understand that it's the h and it's the k that represent the x and y of the ordered pair for the vertex. And there's some really good information right here as well. So let's take a look at this example. We want the directions are determined of the quadratic function whose graph is shown. So I'm using that format right here, that f of x is equal to a times x minus h squared plus k. And based on the graph, I know for sure that my a guy in this equation is going to be positive. I don't know the value yet, but I do know that he's positive, and so I'm going to have a scoop up. Also, based on the graph, I do know the ordered pair for the vertex, and it's -2, -1. Here's the vertex right down here. So the ordered pair for it is I start at the origin, back up 2, and then drop down 1. That's my ordered pair. That means that h in my formula up here is -2, and k is -1. Again, back in my formula. So if I take those two values and plug them into that formula, this is what I end up with. I had a subtraction sign here that came from the format, but my h was negative. That gave me a double negative, which I cleaned up to a positive. And then over here, it was plus k, but because k is negative, it's plus a -1, and then I cleaned that up and just changed it to that. Okay, so that's my formula so far. Now, I need to get a, and what I could do, I need an ordered pair in order to figure out what a is going to be. And I can use the ordered pair from the graph that's shown right here. That's a nice sweet spot. And it happens to be equal to the y-intercept, where the graph actually crosses the y-axis. And the ordered pair for that is 0, 7. So I'm going to take 0 and plug it in for x, and 7 and plug it in for f of x. And then I do all that calculation, and I end up with a is equal to 2. So I take that information along with my a and k, and this is the equation in vertex form that matches that graph. Now, if I had my heart set on it, I could go ahead and take this and massage it a little bit and change it into quadratic form equation standard form. So there he is, and this is x plus 2 squared. So I went ahead and did that, binomial squared, and then pushed the 2 through, and then joined up the +8 and the -1. So this equation, which is in the quadratic standard form, is equivalent to the one that I gave you right up here that was in the vertex form. So I hope that answers the question and is of some help.